Hello friends, welcome to my channel together with Abhi. So far we have covered EC2 introduction, how to launch an EC2 instance, be it Linux or Windows, and how to connect to those instances. Also we have covered the features, bootstrapping, and how to access instance metadata. In this video we are going to cover further theory which is going to be very useful for the subsequent videos, subsequent practical demos. So let's get started. The first thing that we are going to study about is security groups. So you might have seen already while we were launching the instance, we configured certain security groups. But I wanted to provide you further details on that. So what security group is? It is just a virtual firewall. Now you might have seen firewalls at the network level also. If in case you work in some company, there is a corporate network, and to manage the traffic within that network, there are certain kind of firewalls. But this firewall, this virtual firewall is not at the network level, but at the instance level. So every instance that you have launched, every virtual machine that you have launched, it is going to have a security group. This is a virtual firewall. So this is what I just told you about. And this access, the control of this access is based on three parameters. One is protocol, the other is port, and the last is source destination. So as you would have seen, we provided TCP protocol, whether you want to establish an SSH connection or RDP connection, at which port, 22 port or some other port, and what are the source and destination. Okay, so we said the destination or the source could be something like public IP address 0.0.0.0, which corresponds to all the users across the world, any anonymous user. Okay, which is not a recommended setting, but you can provide specific security group or specific IP address also. Fine. Next thing is every instance must have at least one security group. So we saw that if in case we just went ahead with the default settings, it would have created a security group by default. It would have given a security group a default name also if we had not selected it. We just provided security group from our end, but if in case it sees that there is a Linux instance, it would have created a security group which corresponds to SSH connection, and in case of Windows machine, it would have created a security group which corresponds to RDP connection. So this is provided by default. So every instance must have, this is a requirement from AWS. One default security group gets created, as I just mentioned to you. And in case of multiple security groups, rules get aggregated. So you have the option of creating multiple security groups. So let's say if in case you keep one default security group, one is the security group that you additionally provided, and there are two rules within each of them, then the final rule book would be the aggregation of all the rules within these two security groups, and based on that rule book, access to the instance would be allowed. Please note that by default, everything is denied. AWS manages the principle of least privilege. It is not going to allow anything by default. Everything is denied. On top of that, you specify what you want to allow to a particular instance. This is managed through security group. Very important to note, this is a stateful firewall. Note this word stateful because we are going to study in future about ACL, which are network ACLs, which we say are stateless. What do we mean by stateful? So any response which is going out from from your instance, the instance actually notes it. It recollects it. It has the memory of what response, what message has gone out from the instance. So if in case a response to that particular message is received, irrespective of whether it is allowed, not allowed, whether you have defined a rule to allow this message specifically or not, because of the stateful nature of the security group, it is going to allow the corresponding response message, the incoming message. Fine. So if in case you have an outgoing message, corresponding incoming message would be allowed because of the stateful nature. Now this is just the diagram I have taken from AWS documentation. You can refer to the AWS documentation for this diagram, and it just states that security group is at an instance level. This is in essence what it tells. Now let's move on to tenancy options. So when we were configuring the instance, we saw that there are three tenancy options. If in case you go and try to select option, there are three options which are available. The first option is shared tenancy. What it says is, now AWS has got a one physical machine that we say as a host. In that host, it can provide instances from different customers. Not necessarily that one full host machine would be dedicated to some instance. It can house multiple instances from different customers. So this is called a shared tenancy, and this is a default option. The second option which is provided is dedicated instance. Now what we mean by dedicated instance, there is going to be one physical machine, but the hardware is not shared across the entire instances. Rather, a particular section of the hardware is dedicated to some instance which has opted for dedicated instances. All the other instances are going to have the shared hardware. So if in case we divide the hardware into two sections, section A, which is made available to a dedicated instance, and rest of the section B is shared across all the other instances. Okay. And the last is dedicated host. If in case irrespective of hardware, you want to provide the entire hardware, the entire host machine itself to one customer, then that is called as a dedicated host. Obviously, from the options you can make out, the dedicated host is going to be the most expensive, dedicated instance is going to be a bit economical, and shared tenancy is the most economical part of it. Now let's move on to pricing options. We told you that in AWS everything is charged per hour. Okay, if in case till the time your AWS instance is running, you will be charged. Otherwise, you won't be charged. As soon as the instance is stopped, you won't be charged. But within that also there are three mechanisms. One is on-demand instances, which is a default option. If in case you don't even know, your load is unpredictable, whether you're going to require three instances or five instances or one instance, you don't know that. So what you would go with is the most flexible option, which is on demand. As and when you need it, you are going to launch it. It is the least cost effective. Obviously, if in case you know what your load is going to be, if it is a predictable workload, you know that you are going to require 10 instances at this particular point of time, you can have an option of reserved instances. You can get your instances reserved at a much economical price, which provides you almost 75% of savings. Now you can provide this payment upfront, everything, or partial, or nothing upfront, and based on that your cost might differ a little bit, but you will have obviously better option than on-demand instances. And the last is spot instances. So this is like if in case AWS has got a lot of capacity which is not being currently used, what it does is it provides you those instances on bidding. Okay, so they tell you a spot price. This is the spot price, like say $1, and you have to bid. If in case your bidding price is more than the spot price, you get the instance. But you get the instance only for the limited time, only for the time till your bidding price is more than the spot price. If in case tomorrow spot price goes up, it goes to $1.5, and your bidding price is 1.25, you are going to not get this instance anymore. You will be provided with a 2 minutes notice before they terminate it. So you should be utilizing this only for certain non-critical operations where you see that interruption is okay for you. The next is very important section, volumes. Okay, so there are two types of volumes. One is instance store, the other is EBS. Both of them are block level storage. Okay, we had discussed upon file, block, and object. Object storage was something related to S3. Block storage is something related to EBS and instance store. But the difference between these two is mainly on the life of the data. So temporary block storage, if in case you just require temporary block storage, we use instance stores because these are located on the disk that are physically attached to the host computer, and that is why they are very fast. So they are good only for operations like caching and buffer, And these could be used for HDD or SSD based on the instance type. So certain instance type provides you HDD or certain provides you SSD. But the data persists only till the instance is stopped or terminated. Now, I have provided the thing like stopped here. So what happens is as soon as you stop an instance, you would lose the data which is stored on your instance store. People used to make a lot of mistake with that. They would stop it and they would expect that they would still have their data. That is why what AWS did, it has actually taken that option out. So if in case you are using an instance which is backed by an instance store, then that instance won't have an option of stopping also. It would only have an option of rebooting or terminating. In case of rebooting, your data will be available. In case of termination, your data will be gone. Okay. And that is why, because of this short life, this is called as an ephemeral storage. The other option is elastic block store. Obviously, you cannot live with a temporary block storage forever. So you want a persistence. So a persistent block storage is provided using EBS, and you have three options here: magnetic, general purpose, and provision, which we are going to discuss in the next slide. But this provides automatic replication across availability zones, so it helps you with high availability. Important point to discuss here is, if in case you have two EBS volumes, you can attach two EBS volume to a particular EC2 instance. But one block storage, one EBS volume can't be shared across two EC2 machines. That is very important, as it has been depicted in the diagram as well. Now let's discuss on the three types of EBS: one, magnetic, general purpose, and provision. Magnetic provides you the least volume, general purpose something better, and provision has the best. Throughput also, as you can see, provision IOPS has the best. Cost, obviously, for quality, you are going to pay highest cost. But the specificity and IOPS, these are the 2 points that I want to discuss here. So IOPS, input output performance, if in case we have to see, magnetic provides an average of 100 IOPS. In case of general purpose, the baseline is 3 IOPS per GB. What this means, we would want to describe this in detail. So let's say they have a baseline of 3 IOPS per GB. So in case of 1000 GB, which equals to 1 terabyte, we will have 3000 IOPS, right? But does that mean if in case we are going to use 10,000 GB, it is going to baseline to 30,000 IOPS? No, because the maximum performance that you can have is going to be 3000 IOPS. Whether you increase your GB size to 10,000, 20,000, it is not going to matter. But the important thing here is about the IO credit. So it says that the baseline is 3 IOPS per GB. So that means for 500 GB, your baseline is around 1500 IOPS. But because of your traffic, because of your workload, you are just utilizing, let's say, 1000 IOPS. This leaves you with extra 500 IOPS. So this is your IO credit that you have accumulated. So you already have these 500 IOPS accumulated in your account. Tomorrow, if in case you have certain high need, there is a high traffic and you need more IOPS, you can utilize the existing credit that you have accumulated in the past. You can use that until it is finished. So this is really good, and general purpose SSDs, that's why really a good option. However, and a specificity related to provisioned IOPS is, you have the provision of determining or giving an IOPS level by yourself. So you say that I'm going to provision it at a 10 IOPS per GB level. Okay, so you can do that. But the maximum level is still, in this case, is going to be 20,000 IOPS. It is not that if in case you are going to increase the GB to like some really magnanimous value, then in that case it is going to increase your IOPS as well. No, the maximum limit is going to be 20,000 IOPS. The other thing is EBS optimized. As you would have seen, when we were selecting the instance types, we were having an option. It says whether it is EBS optimized or not. So what this EBS optimized is, AWS has a technology wherein they have optimized the EBS in a manner that a dedicated capacity is provided for IO, for the iOS, for the EBS only. So there is no interference with the other normal traffic to instance. So when there is no interference because of any other traffic, the input output operations can be really fast and efficient. And that is why it is always good to have instance type which has EBS optimized. I hope these three types are clear to you. Now the last thing that we have to discuss is the snapshot. Now obviously you would not want to have instance store because it is temporary. You want persistence, but if in case you terminate the instance, that would go away as well. If in case you have checked an option that on termination your EBS volume also goes down, then your data is lost. If you don't want to lose the data, or if you don't want your EBS volume to be attached or to be mapped permanently to one instance, what you can do is, or even for an option of backup or recovery, what you can do is you can take a screenshot or a snapshot, point in time snapshot of that EBS volume. Okay, so if in case you lose the data and you want to recover it, based on that snapshot you can recreate your volume. Now this is done using an S3 technology, but that doesn't mean that it is going to store your snapshot in your S3 bucket, or you will have control in your on your S3 bucket for that snapshot. It is entirely managed by AWS. Taking snapshot is free, but there is a price for storing the snapshot data, and snapshots are available within a region. So let's say if in case you have taken a snapshot in an Asia Pacific region for a volume, and you want to recreate this volume in some other region, say North Virginia or something, what you will need to do is you will have to copy the snapshot to that particular destination region, and you will have to recreate the volume in that region with that snapshot that you have copied. Also important to note, data is loaded lazily. So when you are going to click snapshot and going to click create volume, your volume will be created immediately. But that doesn't mean the entire data has been loaded. The data loading is done lazily. Also, you would have seen, like when we are used to select storage volume, the last column is going to it used to tell us whether whether it has encryption or not, whether it utilizes encryption techniques or not. So what it means is the data stored within the volume, has it been encrypted using one of the techniques that we have discussed earlier using S3. So the techniques are going to remain same. There are going to be no new techniques. You are going to use master key. It has to be either managed by you or by AWS based on that, and whether it is going to be in KMS or something. So we already have covered that in detail. You can go back to S3 module and you can see that what we had discussed. So it is going to be an encryption at rest. For the volume also, EBS volume, it is going to be the same concept. But if you create a snapshot of an encrypted EBS volume, the snapshot data would also be encrypted. But this doesn't actually, you will not actually see about this. As in case of S3, everything is encrypted and decrypted automatically. So you actually don't get to see it, but because of security purpose, we really want to have this, or maybe because of regulatory requirement also, you might want to have encryption. It is a very easy option. You just have to tick a checkbox for encryption or decryption. So guys, that is all what I had to discuss for today. This is really important for us to actually go forward and have some practicals and demos based on these. We might have already seen a few practicals which refer to this theory, but it is good to know about it more so we have a better understanding in the subsequent practical and videos when we see these theory concepts in action. Hope you like this video. Please do like, share, and subscribe to my channel if you really like the videos. Thanks for your time. Thank you.